How are you, everyone? Good. So I was thinking, Friday elevators are less crowded, so I'll go to class very early today because I came almost 20 minutes ago. So I was like, oh, everybody will be like there because they have their PLT and everything. And then when I went to the first floor, two elevators were stuck. Only one elevator was working. There's a long line. Man, I was like, what's wrong with the elevators today? And one of the elevators is stuck on the 10th floor in this floor. So when I get out, I kicked on the elevator. Sometimes, when you kick the elevator, it works. So I hope it will be working now. So people in the downstairs, they can come up. There are also a few wheelchairs there. Like if wheelchairs enter the elevator, then people cannot, like many people cannot enter it. So they are like considering one another. And there's a huge line downstairs. So anyway, that's why I'm 5 minutes late. Okay. So how are you guys doing today? How was your PLTL? Good. So just a reminder, your exam 2 will be exactly 1 week from today and next week Friday. Try to come early. Unlike me, don't be late. See, you don't know what happens to your elevator when. So it's always better on the exam days to come at least half an hour early. Plus, you have your PLTL before class. So I think you don't have to worry about being late, right? If you go to your PLTL, definitely you cannot be late in the class. Okay, anyway, so in our last class, we learned new rules, which were about negative powers and fraction exponents. And we did many examples. From all these examples, there will be at least 1 or 2. I don't remember exactly how many. 1 or 2 questions will be in the final exam. And definitely at least 6 of them will be in the in-class exam. Okay? So if you are absent and you have no idea what's going on, I already posted the video from last class on YouTube. And let me show you again. When you go to the channel, you go to the first playlist, which is our class. Let me go to the playlist. So when you click on the playlist, view playlist, my hand doesn't work. See on the right side, it has all the videos. And yesterday I posted 13. Today I'm going to do 14, lecture 14. So if you miss anything, if you miss any class or you want to revisit the lectures, then you can simply go to the videos and rewatch everything. Any question before you start? Any comments, concern, complaint? Nothing so far? Okay, so what we learned so far, the basic exponent rules, few of them I posted on the side. Anything not 0 to the power 0 is 1, and 0 to the 0 doesn't exist. Then when you have two powers together with one base, you multiply them. When you multiply the base, you add the powers. When you divide the base, you subtract. And based on the position of the higher degree, you keep that position. More base, but one power, you distribute. You're doing division on the power, division on the base, then you distribute. Negative power means it's a fraction. And then if you have a fraction of the power is a negative, still it's a fraction of a fraction. So 1 over a to the fraction, and any type of radical, you can convert that into exponent, but the exponent has to be fraction exponent. So the radical, what type of radical you're taking, like square root means 1 over 2, cube root means 1 over 3. So whatever radical you're taking, that's the base to the power 1 over that number. And we learn other rules also, more rules, but these are the basic ones. Now, if you apply the rules, here we have x to the 1/3, and you're multiplying x to the 2/3. So what do you do? Add the powers. So keep our base, and we have 1/3 plus 2/3. And how much is 1/3 plus 2/3? It's a baby stuff, right? The same denominator, we add them, and what do we get? 1. In other words, it's simply x to the 1, which is the regular x without any power, visible power. So your base can have fraction, whole number, positive number, negative number, it doesn't matter. If you multiply your base, you always add your powers. The next one, let me rewrite. B to the negative 49 times B to the 29. So what do we do? B to the negative 49 plus the 29, and we have the same base, so same denominator. So negative 4 plus 2 gives us negative 29. So we have b to the power negative 29. Are we done? No, we cannot leave negative power alone. We must convert that into positive power. So how do you convert negative power into positive power? You put it on the denominator. So b to the positive 2 over n, and 1 goes on the top. Any question? Was any part unclear? No. Let's see the next one. Next one doesn't have any fraction power, but it has a combination of positive power, negative power, everything. Any idea? What do you do first? Mustafa. Only negative 2 and 3? Okay, but our base has more terms, right? It has 4 and it has x to the negative 3, and both of them have power 3, right? So you have to distribute the power. 4 to the power 3, x to the negative 3 to the power 3. What do you do in the denominator? Same thing, right? Denominator also has the same thing. So negative 2 goes to the 6, negative 2 goes to the x to the 4. So 6 and x to the 4. Both of them have negative 2 power. So step 1, distribute the power. Distribute the outer power or outer exponent. And then what can you do? Any idea? Remember, our goal is to apply all the power rules. So if you look at the variable, what exponent rule you can apply here? We have one base but two powers. Do you add them, multiply them, subtract them? What do you do? Multiply them. So we have x to the negative 9. And on the bottom, what do you have? X to the how much? Negative 8. Now leave the power for the number. Why? Because one of them has negative power. Don't do anything with the negative power until you convert all the negative power into positive power. Apply the right. Apply the exponent rules and then convert all the negative power into positive power. So let's start with the numerator. X to the 9 is negative. How can you make it to x to the positive 9? What can you do so that x to the negative 9 turns into x to the positive 9? Turn into fraction. In other words, bring it on the denominator. 4 cubed doesn't have any negatives, so we leave it alone. 4 cubed is right. It stays on its position. Now 6 has a negative 2 power, but we want 6 to the positive 2 power. So what can we do? Bring it up. And now last thing is x to the negative 8. How can you make it into positive 8? Bring it up. So all you have to do is switch their positions, whatever has negative sign, negative power. As a result, on the top, we have 4 cubed. And now 6 squared, because we moved it from the denominator. And also we moved x to the 8 from the denominator. So 4 cubed has to stay on its position because it doesn't have any negative power. The other three things, three elements, I forgot. 3 things, they have negative power. So we just switch the positions. X to the negative 9 is on the top. We have to put it on the bottom in order to make the negative 9 into positive 9. And now, last thing I'm going to do is apply the exponent rules again to simplify. So 4 cubed. How much is 4 cubed? 4 times 4 times 4, how much? 64. And then 6 squared, 36. And then we have division with the individual exponent. So how do you combine them? In division, what do you do with the powers? Do you add them, subtract them, multiply them? Subtract them. So which one we are going to keep? X to the 9 or x to the 8? X to the 9. And where is x to the 9? On the numerator or on the denominator? So we have to keep our x to the 9 on the denominator, and we need to subtract 8 from the numerator. So that's how we combine the division And now we know 9 minus 8 is 1. So we have a simple x on the denominator. And we need to know what is 64 times 36. 6 times 4 is 24. 4 goes on the bottom, 2 goes on the top as an addition. 6 times 6 is 36, plus the 2 is 38. Then we place we put a placeholder 0, and then it's the same multiplication. 3 times 4 is 12, 2 goes on the bottom, 1 goes on the top as an addition. 3 times 6 is 18, plus that 1 is 19. So we add all of them. We get 4, 10, 9, 10, 11, 12, 13, and 2. So 8 plus 2 is 10. We put 0 here and 1 on the top as an addition. 9 plus 1 is 10, plus 3 is 13. So 3 goes on the bottom, 1 goes on the top as an addition. And we have 1 plus 1, 2. So in the numerator, we have 2304, and the denominator, we have x. And one of these will be in the final exam. Was any part unclear or confusing? Any question? No question, nothing? Okay, then. Let's see how many more we have. Oh, only 2? Oh, man, I want to give you a lot. Anyway, so you have 2. Work with your neighbor and do them. Let me take your attendance now. Janisha, yeah. Eliza, Memona, yeah. Fabricio, yeah. Sergio, yeah. Miley, yeah. Hamlart, yeah. Oliver, here. Himadri, oh, absent. Mustafa, here. Jacqueline, here. Jiain, here. Anaya, here. Jason, here. Atsiri, here. Anthony, absent. Joseph, here. Sitlali, here. Saida, Muhammad, Ronaldo, Daniel, Jeremiah, Camila, Philia, Haley, absent. Jasim, one, two, three, four, 5 absents. Let me remind you again about your attendance. Attendance, including your homework and quiz, at 20% of the grade. So the more days you get absent, the more points you're losing from your 20%. And I gave you only 4 days chance. you're allowed to be absent for 4 days, and except for the 4 days, every other absent will be counted. Okay. If you're done, check with the neighbor, and if you're stuck, get help from the neighbor. All the negative into positive. That's great. This one. I did not that, right? Oh yeah. Oh, so. Yeah, distributed, but how can you multiple people choose the power between the reals? How can you multiply that? It's cutting wrong. It distributes the power. So it's six or that's six. And here it's 2 to the negative 2. That's 2 times negative 2. Go around with the
Yeah, this is gonna be rich. Here next to my door. Here, we want to remember that these numbers also different. So the 6 get the 6 squared, and the 2 gets the minus 2 squared. I should that's the thing multiplied. But here, we want to remember like this whole thing. So exponent. Yeah, we got so we have x in the fixed and a number, and negative taking x in the negative. So because it's negative, we want to think around. Yeah, we don't want to turn it. We want to take the whole thing and bring it home. So this x in the negative function right over here, and it'll be x in the negative. So then I'll come back to that. Yeah, this is. So that's whole thing. With this 8, it's all the lifetime of the number of they wherever they go. Wherever the bigger number is. But the denominator doesn't have 2 colors. I can do 2 colors. One is over like everything over 2. That 6 over 2. They like where it was. It wasn't affected by like we multiply. We square them. This one has to be squared. And then like if they are connected to the everything's really everything's all yeah, it's not like
Sorry.
it's like
No. At the stage here. Properly. I originally was fine. Oh my gosh.
But numbers No, I mean, part of the top, or actually the. And then C is bigger to one. So, on the next one, you can do. Yeah, to this bag, it's following. I'm solving.
Remember, one of these will be in the final exam. So step one, we distribute always out. So we have 6 x to the negative 3 on the top, 2 x squared on the bottom. Top has power 2, but bottom has power negative 2. Then you have 2 powers together, so you multiply them. So 6 squared, if you want, you can write 36. And then we have x to the negative 3 times 2, not 3 square, okay? You never seen me doing any power of power. I always multiply the power. So x to the negative 6. Don't write 2 square, 2 to the negative 2 as negative 4. That is not negative 4. Don't touch your negative power until you convert negative into positive, okay? So 2 to the negative 2. And now only 36 is good. Everything else are bad. So we need to switch them around. This comes down. This goes up. Also, you see x. And this also goes up. So all the negative, they will move around. Whatever has positive, they will stay on their position. So 36 times from the bottom, we get 2 squared. And also from the bottom, we get x squared. And from the numerator, x to the negative 6 comes down and turns into x to the positive 6. So we have 36 times 4. And by applying the power rule, so applying the division rule, oh, 4. Thank you. So when you apply your power rule, division rule here, so denominator has to stay on its position and you subtract the power from the numerator. And then you do manual multiplication. What is 36 times 4? What is 36 times 4? 144. And we have x squared. You have to stop here because you are not doing any solving equation. So many of you wrote this as 12 over x. This is not 12 over x. This is 144 over x squared. It will be 12 over x if you try to, if you have two sides of the equation, like for example, x squared equals 144 over x squared, and then you take the square root, then it makes sense to do that. But here you don't have any two sides of the equal sign. So definitely this doesn't make sense here. Okay. But since most of the time these are multiple choice questions, so you may see 12 over 6. So 12 over x. And if you pick that, that's it. Boom. You get 0. So be very careful. Multiple choice are tricky. The next one is same, but much easier. We have x squared to the 4 and 2x to the cube. They don't have any negative power. So once we distribute, we just combine like terms. 2 powers together, we get x to the how much? 8. And on the bottom, we have to distribute the power because we have more things on the base. So it's 2 cube and x cube. So 2 cube is how much? 8. And if you observe, we have a division with the x's. So which x is bigger, numerator or denominator? Numerator. So we keep our numerator x and we subtract the smaller one from the denominator. That's how we get x to the 5 on the top and only the number 8 on the bottom. Any question? Oliver. Okay. So let me redo it. So we have 2 times 2, 4, and x to the negative 6 on the top, 2 to the negative 2 on the bottom. Are you clear up to here? Okay. Now you have to switch around whichever has negative power. 36 doesn't have any power. It is 1 power, so we keep our 36. Actually, let me write here. So on the top, 36 doesn't have, we keep it. But x to the negative 6, it has a problem, right? It's negative power. So we have to bring it down and make it x to the positive 6. Now we go to the denominator. Denominator has x to the negative 2. We have a problem, right? So you have to bring it up to make it positive 2. And then the last thing is x to the negative 4. We have a problem, right? Negative power. So you have to bring up to make it positive 4. And now you see we have division for the x. So which x is bigger, the numerator or the denominator? So you keep a denominator and you subtract the smaller numerator. So we get x squared. And on the top we have 36. And now we have 2 squared, which is 4. When you multiply 36 and 4, you get 144. Any other question from anyone else? Was everything clear? Okay, so this is something that will not be in the exam, but it's in your homework. They are saying multiply, but this time it's fraction power. So this is same as x times x minus 2, something like that, okay? Previously we did multiplication, something like that. So we know all you have to do is distribute the outside factor to the inside one. So same concept. We distribute. So we have x to the 3/5, and you're multiplying x to the negative 1/3. Then we have negative x to the 3/5, and you're multiplying x squared. Any questions so far? I did nothing, I just distributed them. And now you're going to use the exponent rules to combine the powers. So we have same base, but more powers, they're multiplying. So how do you combine? Do you add, subtract, multiply, or divide? We actually never divide anything. So do you add, subtract, or multiply the powers? Add. So we keep our base and we add 3/5 plus negative 1/3, which is simply minus 1/3. Right? If you have plus and minus 1/3, this is same as minus 1/3. Same thing here. We have x to the 3/5, and this time 2 doesn't have any negative sign, so we just add the 2. The rule says add your powers, we added the powers. But now we have algebra problem. Our denominators are not same. So we need LCD. What is the LCD between 5 and 3? 15. That means we want 15 on the first denominator. What can we multiply by 5 so that it becomes 15? 3. So we multiply top and bottom by 3. And what do to multiply the second denominator by? 5. So multiply top and bottom by 5. So now all the denominators have 15. We go ahead and combine the numerators. 3 times 3, 9. Minus 1 times 5, 5. So that gives us x to the 9 minus 5. What is 9 minus 5? 4. So these are first term. Then we go and combine the second term. The first denominator has 5. So we want what below 2? Same 5, right? Unless we have the same 5, we cannot combine them. So we want 5 here, but we cannot just randomly put 5 here. We also have to put 5 on the top as a multiplication. So multiply top and bottom by 5. And now we have 5. So we combine our top. 3 plus 2 times 5, 10. So in the second term, we have x to the 10 plus 3, 13 over 5. And then don't worry about anything else, we are done. That's how we distribute fraction powers. Same as normal distribution, but we do more because this is fraction. So we have to have the same denominator to combine the fractions. Question? Good news, this will not be in the exam. But bad news, you have your homework and quiz. Same thing, but this time it's binomial times binomial. So we do distribution twice. We take the first term and we multiply to everything on the second term. So x to the negative 1/2 times x to the positive 1/2. And then we have a plus sign. Actually, let me do it this way so that you don't get confused. Plus 3y, and then we have minus 2. We convert that here. Minus 2 times x to the 1/2 plus 3y. And now each of them is just like the left page. So we get x to the negative 1/2 times. Then we have a plus. So we multiply x to the negative 1/2 times the 3y. Is it 3y or 3x? I don't know. Let me keep the y. And then we do the same thing here. We have negative 2 times x to the 1/2. And we have negative 2 times the 3y. So only this has same base. Everything else, they don't have same base. So we apply the same base rule. When you have same base and you're multiplying, how do you combine the powers? Add. So we have negative 1/2 plus the positive 1/2. And what happens to negative 1/2 plus positive 1/2? They cancel out and become 0. So we have x to the 0. On the second term, we have two different variables, so you cannot combine them. So 3y doesn't have any problem, we keep it. But x to the negative 1/2 has a problem, its power is negative. So we bring it down to make it positive 1/2. X to the positive 1/2. The next one doesn't have any problem. So negative 2 x to the 1/2. And lastly, we have negative 2 times 3, which is 6y. So we have 3y. X to the 1/2 is square root of x. So we can just write nicely square root. Same thing here. It's 2 to the square root of x minus 6y. And I think we can leave them alone, except for one case. What is x to the 0? Good. X to the 0 is actually 1. So we have to rewrite this as 1. And now we are done. Let's see why. You can actually do more. We can combine the square root to the square root by having the same denominator and everything. But don't know about that. I think my method will accept that. I hope it does. Oh man, more. Okay, one more. Factoring out. So the background knowledge you need to factor out anything is that the meaning of factoring out. Factor out means divide. Okay, you have to remember this expression. When you factor out something, It means you're dividing whatever is given by the factor you're taking out. So it says from this expression, factor out x to the negative 1/5. Factor this out. So when you factor out x to the negative 1/5, so this is same as, let's say you have 2x squared minus 7x to the 4. Okay. So normally when you factor out, we take out the x squared and we get 2 minus 7 another x squared, because 4 minus 2 gives us 2. So similar concept is here. We have 2x to the negative, actually let me do this on the other side. We have 2x to the negative 1/5, and they're telling us, hey, factor out x to the negative 1/5. It means divide this by x to the negative 1/5. What do you see? On the numerator, we have a negative x to the 1/5. On the denominator, we have x to the negative 1/5. So they would cancel out because they're the exact same thing. So what remains? 2. So when you factor out x to the negative 1/5 from the first term, you get 2 only left. And then you have a negative, this one. Now the second term is 7x to the 4/5. You're taking out x to the negative 1/5. It means you're dividing this by x to the negative 1/5. This is what taking out means, factoring out means. But this time they don't get cancelled out because they're not same. What can we do here? Good job, subtract. So we keep our 7 and we have 4/5. Obviously this is bigger, right? Oh, never mind. Remember I said don't do anything until you convert the negative sign into positive sign. So we have to bring this up before we combine them. So we get 7x to the 4/5, and from the denominator we get x to the 1/5. Then you don't have to subtract, you can simply add them. We don't do double subtraction. Now we have a multiplication, so we add the powers. We get 7x to the 4/5 plus the 1/5. Do we have the same denominator? So we keep the denominator and we combine the numerators. What do we have? Which is 1. So you have simply 7 and x to the 1, which is just 7x. And that 7x goes here. That's it. This is called factoring out. Good news, this will not be in the exam. But there will be any quiz, my math lab quiz and homework. So for Tuesday, you have your homework 5.2, 3, 4, 10.2, their homework and their quizzes. This will not be in the exam, this will not be in the final. This is just for your knowledge and to complete your homework and quizzes. Any question on any of the exponent rules? No question? Okay, then we are done with chapter 5 and 10.2. Now we are going to start chapter 6, which is factoring. So I'll actually save this. Bless you. So chapter 6 has 7 sections to cover. For this exam, my plan is to do 6.1 and 6.2. Probably we can finish it. All you have to do is factor, that's it. Now, since we did factoring in the last question, we are going to the same factoring here, but this time let's start with something easier. For example, what factors mean? Factors means if you can divide your number into pieces, what pieces they can be. For example, 3. 3 has only 2 factors, 3 and 1, because 1 times 3 is 3. On the other hand, 4 has 3 factors. 1 times 4 is 4, so 1 and 4 are 2 factors, and 2 times 2 is also 4, so 2 is another factor. But 16 has more factors, 4 of them, 3 of them actually, 4, 3. 1 times 16, so 1 and 16 both are factors. 2 times 8 is 16, so 2 and 8, they both are factors of 16. And 4 times 4 is 16, so 4 is also another factor. So 16 has 5 factors. So factors are things by which you can divide your number. Now, same thing for polynomial. Polynomials, when you have 3 terms, we call them trinomials. And when you have the highest degree 2, we call them quadratic. So this is a quadratic expression. We can easily factor a quadratic expression. And the factors, if you multiply them, you get back the same polynomial back. So polynomial, we can factor, and if you multiply the factors, you get the same polynomial back. That's how we can identify whether our solution is correct or not by multiplying the answers. Forget about all of this. We are finding GCF. In order to factor, we need the greatest common factor. So this is called GCF. How do we find GCF? Between 12 and 20. So we look at all the factors of 12. We know 12 is 1 times 12. And also it's 2 times 6, right? And it's also 3 times 4. So the factors of 12 are all of these. Now we look at 20. 20 is 1 times 20. And oh no. I missed my 2. So 1 times 20, 2 times 10, right? What other factors do we have for 20? 4 and 5. 4 times 5. So these are all the factors of 20. Now GCF, it means which factor you see in both of them, and that's the largest factor. For example, both of them have 1. Is it the largest one? Both of them have 2. Is it the largest one? Then both have 4. Is it the largest one? Yes. So a GCF is 4. The largest factor that you see between both of them. Okay. So when you take out GCF, we look at all the factors. We do it mentally. We think of all the factors each number has, and you see which one we find in both numbers. Now, GCF for variable is kind of different. So we have y squared. It means y times y, right? Y squared. Then y to the 4. It means we have 4 of them. Y to the 7. It means we have 7 of them. Now, how many y's you have in all three? What is the largest number of y you see in all three of them? Two of them. So your GCF here is y with that 2 power. Okay? For number, we see by which number we can divide both of them. And for variable, if you're finding the factor, it's usually always the smallest power, because the smallest power is visible to all the factors, all the variables. Clear? Now, can you find the GCF of these three? Look at the numbers separately and variables separately, and figure out what would be the GCF for all three terms. Two x. Perfect. The answer is 2x. You may wonder how? Look at all of them separately. 8 is 1 times 8 and 2 times 4. 6 is 1 times 6 and 2 times 3. 10 is 1 times 10 and 2 times 5. So what is the largest number you see in all three? The 2. That's why 2 is the GCF of the numbers. And for variable, we have x, x squared, and x cubed. So x means only one of them. X squared means two of them. X cubed means three of them. So what is the largest amount of x you have in all three? One of them. So for the variable, if GCF is the smallest power. For the number, it's the largest number by which you can divide all three. Now, these are the rules we're going to use. When you have two terms and you're factoring, there are two choices. Either you're pulling out GCF from the two terms, and then we have another choice. The two terms you have, they are the difference of perfect squares. For example, you may have something like this. 2x plus 2. So it's asking to factor. What can you factor here? Both of them have what? 2 in them, right? So you pull out a GCF 2. And we get x plus. You pulled out the 2. So you don't have any more 2. What do you have? 1. Remember, pulling out means you're dividing. So 2x divided by 2 is x, and 2 divided by 2 is 1. You're left with x plus 1 once you factor out your 2. So 2 terms means you have some type of GCF, or you may not. And then you have another choices. The two things you are given, probably they represent difference of squares. For example, x squared minus 4. They have nothing in common, right? They don't have any GCF. Their GCF is 1. Everything has 1 in them. So it doesn't help us. But if you rewrite this as x squared minus 2 squared, now we have difference of perfect squares. And do you remember from our last class or the class before that? When you have difference of perfect squares, we can easily factor them. What factors we get from this? Their names are conjugates. X plus 2, x minus 2. So you simply take their bases, add them, subtract them. That's the two factors of difference of perfect squares. So previously we had the conjugates, we multiplied, and we said the result is x squared minus 4. And I also told you at the same time, when you factor, you go backward. You're given the difference of perfect squares, and you split them into two conjugates. So two terms means you have two choices. Either it's GCF or it's perfect squares. And then we have four terms. When you have four terms, you have only one choice. It's called factor, but so two choices again. Either they have GCF in common, all four, or you have to factor by grouping. Four terms you factor into two groups, and then you take out GCF for each group using the GCF method. So two terms mean two choices. Four terms is also two choices. And then for three terms, we have many choices. We're going to learn one by one. But now let's do some easy problem. Between 40 and 12, what can you factor out? A 4, right? This is divisible by 4. This is also divisible by 4. So you can factor out a 4. When you factor out a 4, t plus 3. Great. N is t plus 3 because factor, when you factor out 4, it means you're dividing each term by that factor. So this cancel out, you get t, the first term, and 12 divided by 4, you get 3 for the second term. How about the next one? X plus 2y. They have nothing in common, right? So when you have nothing in common, we say it's not factorable. And they have a special name. They're called prime polynomial. Prime means you cannot do anything with them. It's prime, just like prime numbers. They don't have any factor besides 1 and themselves. Now look at here. Y to the 8 and y to the 4. So what's the common factor? Y, but they have different powers, right? So you have to take at least some power. Y to the 4, the smaller one. So pull out y to the 4. If you get confused, y, think of this, y to the 4 and y to the 8. So 1, 2, 3, 4. And here we have 1, 2, 3, 4, 5, 6, 7, 8. Both of them have how many y's? 4 of them. So you pull out 4. And then you left with how many from the 8? Not 2. See, you have 8, you pull out 4 of them. How many left? 4 of them. And you had y to the 4, you pulled everything out. So what is left? 1. You pulled everything out. In other words, you have y to the 4, and you took out y to the 4 as a common factor. They cancel out, you left with 1. And for the other one, you have y to the 8. You pulled out y to the 4. In division, we subtract the power. So you have y to the 8 minus 4. which is y to the 4. Any question? No? So in our next class, we are going to do more example with four terms and then with 3 terms. And then you'll be ready for the exam. So in our next class, I'm going to tell you how many questions, how many questions I'm planning to give on the exam, but this time we're not going to do any review because we didn't have time. And Thursday, we have no class because Thursday follows Wednesday schedule. We are going to go all the Wednesday classes on Thursday. Tuesday we'll meet, but Thursday we're not going to meet.